Here is our study area. It represents 340 million years of Earth history. The yellow shows young, loose Holocene and Pleistocene epoch sediments. The pale blue shows a variety of Permian rocks that overlay the older Carboniferous rocks. They are full of life, with shelly fossiliferous layers, plus freshwater layers with plant fossils and coal seams. The colourful, highly folded rocks consist of Carboniferous lavas and sediments. We will play time detective in this picturesque holiday spot. Our first stop is the Mount View lookout near Cessnock. The rock is pale, hard, and lacks big crystals. This tells me that it is a silica-rich lava of the sort that block volcanoes, causing catastrophic explosions. You get a mushroom cloud, which blows sideways, incinerating everything. The result is a rock called Ignimbrite. Very fine ground mass, and a few crystals welded together by heat. The heat is obvious in this Icelandic volcano that erupts through ice. This welded Ignimbrite under a microscope shows glass with flow lines surrounding quartz crystals. Now we look at the Mount Bright rhyolite Ignimbrite. There are a few tiny crystals here, grey quartz and pink felspar. You may be able to see the flow lines in the pale-coloured ground mass. The lava has been dated radioactively as 320 million years old. This map shows the Williams River that branches off the Hunter River at Hexham and heads north through Raymond Terrace towards Paterson. The yellow sediments on the left are silts valuable for farming. The dark blue is Permian rock layers between 250 and 300 million years old. This is the main highway between Raymond Terrace and Grahamstown Dam. It is no longer safe to walk there. Permian rocks south of Newcastle are flat, but here they are tilted as they are part of the New England fold belt. Can you see fossils in these siltstones? The main ones are brachiopods, which lived in the mud and filtered out plankton through tubes that sucked in seawater. This little fellow is a gastropod. Both these species died out at the end of the Permian. Travelling north on a road next to the Williams River, we pass from Permian into Carboniferous rocks. There is a small quarry on the left between the road and the river. On the left of the quarry, the rocks are vertical. This sudden change in dip is caused by the presence of a fault line along the river. This is one of the many faults that crisscross the New England fold belt. We continue along the road and cross the river into Seam. This map shows a 600 metre thick Seam formation in yellow. It contains 5 volcanic layers that are mined for road gravel. The radioactive dates range from 305 to 327 million years. But other silt and conglomerate layers in this formation are of more interest. On the corner of Cross Street and Torrance Street is a national monument dedicated to pioneer Professor Edgeworth David, who described the Seam Formation rocks in 1920. He had seen similar rocks in England and realised that they were varved shales deposited by meltwater from glaciers. He also noticed drag folds caused by ice moving over the silt layers, as well as animal tracks, ripple marks, and drop stones that had fallen into the sediment as the ice melted. To the north of the Seam Formation is the Walleringa Formation. This conglomerate is a tillite left by a retreating glacier. The pebbles are of all shapes and sizes, gouged out by glaciers as they advanced, and dropped when they retreated. From plate tectonics theory, we now know that Australia's position in the Carboniferous was near the South Pole. The Carboniferous period was named after the massive coal seams produced by the forests of Britain, Europe and America. I collected these local plant fossils of the Australian seed fern Rhacopterus that clung to life in an environment of exploding volcanoes, snow and glaciers. Silica-rich lava domes produce less than normal gravity force within the Earth's crust. Using gravity measurements, geologists have located 3 Carboniferous calderas in the area that kept blasting Ignimbrites from their massive craters. Some of these rocks have been quarried. The quarry at Irrawang was mined for dacite Ignimbrite, and at Martins Creek, Patterson, for andesite Ignimbrite. Both were grey-coloured rocks. The latter is sometimes called salt and pepper rock. The black crystals are hornblende and pyroxene, and the white crystals felspar. The grey is ground mass. Volcanoes in New Zealand, New Guinea, Indonesia and Japan have similar lavas. So now we can picture the area in the Carboniferous. Snow-topped mountains in the west, with glaciers and explosive volcanoes blasting through ice along the Air volcanic rift shown in red. Vegetation clings to life in the rich, volcanic, frosty soils. The Grahamstown Dam was built in 1956 and linked by the Ballakira Canal to the Williams River. As we pass the dam and head for Port Stephens, we pass a series of sand dunes. The Pleistocene epoch began 2.6 million years ago when the climate cooled and the poles were covered by thick ice. Superimposed on this have been violent fluctuations in temperature of around 10 degrees Celsius. This is the last 800,000 years, with warm periods in yellow and cold in blue. In cold periods, the sea level drops and the wind blows hard and dry with lots of sand. In warm periods, the sea rises 120 metres and floods the rivers, estuaries and coastline. This map shows this. Bedrock is in purple. The orange is older Pleistocene dunes. The rest are Holocene sediments and dunes that formed as the sea level rose 11,200 years ago. These Holocene dunes along Stockton Bight are something of a tourist attraction. This map shows Port Stephens with Carboniferous rocks in orange and dunes and finer sediments shown in yellow. We will start at Soldiers Point on the top left and work clockwise. Port Stephens has an inner and outer bay, with Soldiers Point being the choke point between the two. There is an island and a deep channel at the end of the point, cut by a river that flowed fast in glacial times. At the end of the beach are rocks that consist of the Port Stephens rhyolite ignimbrite. Here it is rather glassy. The quartz in the rock is responsible for the white sand on this beach. I found these artefacts in the water across the point. The local Warramai people fished from bark canoes, braving the sharks for thousands of years. We follow the shoreline to the anchorage resort at Corlett Point. On the west side of the resort are some rocks. They are not volcanic, but consist of pebbly conglomerates and sandstones deposited in fast-flowing water, probably in a freshwater environment. We move on to West Point, that is the site of an old wooden wharf dating from the war, and is now occupied by Dalbora Mariner. There are tracks leading west through the scrub down to these rocks. The rocks are grey, andesite ignimbrites. The rock on the left is pitchstone, which cool the fastest at the base of the flow. You can see the glass under the microscope. Gangan Lookout is central to the Port Stephens area, next to the old army base. It provides us with a good picture of the local geology. The view west shows the inner dune areas and waterways. The map shows that the volcanic peaks of Port Stephens are part of an anticlinal fold in dark purple, which is shaped like a horse's saddle. The hills are on the eastern part of the saddle. Can you see that the lava layers in these hills are dipping towards the southeast? How many hills are here? One is an island. The angle of dip on these lavas is the same as the dip on Yakobo Headland in the distance. What is the angle of dip on these rocks on the north side of Nelson Bay Lighthouse? The other cracks in the lavas are joints. What may have caused these cracks? This shot is taken facing north on the other side of the hill. The black rock in the foreground is made of dolerite. It is a 1 metre thick wall of magma that intruded the older rock and solidified whilst still underground. We call such structures dikes. There are 60 such structures in the local area. We leave this headland by boat. Our destination is Yakobo on the left and Tomaree on the right. Yakobo is a northern headland. There are 2 perpendicular notches where the jointed lavas have collapsed and fallen into the sea. Fault lines may be a problem. Tomaree was fortified in the war. The interesting feature is the vertical chasm that may be the remains of a weathered dike. Both these headlands and the coastline south feature the Port Stephens rhyolite ignimbrite, a pretty rock high in potassium which plants value. Early geologists called it Toscanite. It contains pink and white felspar crystals plus grey glassy quartz crystals. The salmon groundmass can only be viewed with microscopes. Grey dikes in the rest of this video litter the coast south and are believed to have been formed 50 to 80 million years ago when ancient Zealandia split off our coast. See my video on that. In the meantime, what do you observe, detectives?